Hey, ladies and gentlemen, boys and girls, welcome to another episode on the Incredible Academic YouTube channel. Right, so today we are going to be covering functions as per grade 12 ATP. So this is in term 1, and this video is being recorded on the 31st of December 2023. And I hope you guys enjoy your New Year's Eve, right? And all the best for 2024. So, without wasting much time, let's just get right into it. So, functions. I like this topic because this is where we actually, sort of like going down to the basics. You know what I'm saying? We're not discussing stuff that's too complicated, so we're going back to basics. What is a function, right? What is a function? And in the textbook that I'm using, obviously they're talking in terms of input and output, right? And that a rule, that a function is a rule, okay? And I'm going to pick, the definition that I like, right? Which is much more practical and easier to understand, right? So, according to the textbook, a function is a rule, right? Together with a set, right? By means of what? By means of which each element of the given set, right? Of the given set. Each element of the given set, right? Each element of the given set is associated with what? Is associated with one and only one. Very important. One and only one element of the second set. Element of the second set. We'll discuss that. Don't stress too much about it. In fact, the definition that I meant to write down is this one. Alright, a function. This is the one that I actually like. So a function is a relationship, right? This is not too conceptual, right? A function is a relationship, right, between two sets, okay? A and B, right? Where every element of A is mapped to only one element of B, to only one element of B. One element of B. Now, okay, I know some people don't like definitions. You look at the definition and you realize that no, it's not make sure. You know what I'm saying? It's not making any sense. So I'm going to look at a couple of examples. Okay, all right. And I'm pretty sure you guys remember these type of boxes that we had in grade 9, right? These type of boxes, right? So you find that, okay, we've got maybe 2 here, we've got 4 there, we've got maybe 6, and then maybe 8 over there. Okay, and in the middle you're given an expression. So let's say the expression is 2 x plus 1. Okay, and then now you asked to find the number there and the number there, right? And these numbers, we call them all the numbers that you're seeing over here. This is what we call the inputs, right? These are inputs. And another word for inputs, it's the domain. Okay, so in other words, when we want to find a certain output, these are going to be our inputs. So these are the outputs or their range. Do you get what I'm saying? So now we know that these actually represents the x values, these represent the y values. So x values, these are y values. Okay, so obviously to find the corresponding y value, we need to substitute x there, right? So if we substitute the 2 there, 2 times 2, that's what? 4 plus 1, that gives us 5, right? So meaning that 2 is mapped to what? To 5. In other words, when we put 2, right, as our input, our output is 5. But what happens when the input is 4? What's the output? So 2 times the 4, that's 8, plus 1, that's 9. So we're getting a 9 here. Right? We're getting a 9. And then that means that 4 is mapped to what? To 9. Right? Can you see? Inputs have got corresponding outputs, domain and range, right? And then 6 times 2 times the 6, that's 12, plus 1, that's 13. So 6 is mapped to what? 6 is mapped to 13. All right, then lastly the 8, we've got 2 times the 8, which is 16, plus 1, that's 17. So 8 is mapped to 17. So a function can also be called a mapping, do you understand? Because you can see that, in fact, this we normally call a set. Okay, so when you hear them talking about set A and set B, so this would assume that this is set A and this is set B, all these numbers that you're seeing over there, right? So we're just talking about a set of numbers. Okay, so now they're saying a function is a relationship between 2 sets, and you can see that you've got the first set here and the second set there, right? It's a relationship between 2 sets, A and B, okay, where every element of A, so every element of A is mapped to only one element of B. So you can see we don't have one element of A going to 2 elements in B. Understand? In other words, it's not allowed for us to have one X value producing 2 Y values. Okay, that would be a problem. But it's okay to sort of like have one y value being mapped to more than one x value. That is not a problem. As you guys have seen with a quadratic function, you find that there's x is equals to 2, x is equals to minus 2, and when you substitute 2 and minus 2 into the function, you find that actually the y value is still the same. So that is still a function. So I'll give you guys a quick example where we don't have a function. So let's look at this one. So let's draw something like this, not a box this time around. So let's say we've got y is equal to plus minus square root of x. Okay, plus minus the square root of x. Okay, so now what we are going to do is we're going to say, okay, let's check what the inputs are going to be. We're going to keep it simple, no complications. This is 1, this is 2, this is 3. In fact, let's use a perfect squares. So 1, 4, 16. What's the other perfect square? Let's just say 49 or 36. Or we could have used 25. Yes. All right. So 1, 4, 16, and then 25. So now you can see that this is set A. Let's call this set A. Are you guys with me? So now we're going to do this. We're going to find the corresponding and remember, this is our domain. That's the domain, and these are the inputs. Okay, so we're going to say fine, let's do this. Let's check the corresponding y values, right? So when you substitute 1 here, how many x values are you getting? You get plus 1 and minus 1, right? In other words, now we've got 2 corresponding y values. So we're going to do this. We're going to have this 1, 2, 3, 4. So there's our set B. Right, so this is set B. Right, so we've got minus 1 here, and then we also got plus 1. We've got minus 2 plus 2, minus 4 plus 4, and then minus 5 plus 5. And you realize that when you substitute your 1, it produces 2 corresponding y values. Do you understand? In other words, the 1 gives us either -1 or +1, right? And then the 4 gives us -2 or +2. Do you understand? So on and so forth. Now, one x value is mapped to more than one y value, and this is not a function. It's not a function, okay? Because one x value is mapped to more than one y value. And let's go back to the definition. Our definition says that a function is a relationship between two sets. Yes. A and B, where every element of A is mapped to only one element of B. But look, in here we've got 1, 2, 3, 4 elements in set A being mapped to more than one element in the set B. Remember, set B has got how many elements? 1, 2, 3, 4, 5, 6, 7, 8. Right? All of them, they are mapped to more than one Y value, right? Or more than one element in the set B, which is a violation of the definition of a function, right? Because the elements in set A they need to be mapped to only one element of B. Then that would be a function. Okay, so that's just, you know, the basics when it comes to defining what a function is. And we'll also talk about, you know, the horizontal, the vertical line test, which is very important when it comes to determining whether a drawn function, a drawn what we call graph is a function or not. All right, so yes. And I don't know if there's anything else to discuss, but we've covered pretty much, you know, everything, right? So we spoke about the sets, right? We've got two sets, right? Depending on how many sets in the domain, how the sets in the domain are mapped to the sets in the range, then we can be able to tell whether we're dealing with a function or not. All right, so that's that. And then now let's look at another function. Well, another graph. We don't know whether it's a function or not. So yes, so let's suppose that we've got something like this. We are given the inputs, right? We're given the inputs. Let's suppose that our inputs are just 1, 2, 3, 4, 5, 6. Okay, and then now this is set A. All right, remember set A, that's your domain, that's your inputs. And then now these are sort of like interlinked by what? The function y. Let's say y is equals to what can we use? X squared. Okay, so all right, so there we go. Right, and then now let's look at the second set. The second set, so this is what? Set B, which is equals to what? The range, isn't it? Range outputs. Okay, so let's check what's happening. If you substitute 1, what are we gonna get? 1 squared becomes what? Just 1. We substitute 2, becomes what? 4. Substitute 3, becomes what? 9, isn't it? We substitute 4, becomes 16. Substitute 5, becomes 25. And then we substitute, lastly we substitute 6, which becomes 36. Okay, so you can see that but also if you substituted if you substituted what we call -1, -2, -3, -4, -5, -6, okay, you'd get exactly the elements in set B. Do you understand? In other words, set A, the elements on the left of set A produce exactly the same output as the elements on the right of set A. Okay, and that is totally fine. We can have many sets. We can have many other elements giving us values in set B. But what we don't want is to have just one element giving us different Y values. Do you understand? Here we've got different elements in set A giving us the very same element in set B. Do you understand? In other words, many elements in set B are giving us a single element in set B. In other words, two elements are mapped to one element in set B. Right? You can see 2 and -2, they're both mapped to 4. Right? But the problem starts when one is mapped to many elements in the set A. Right? So, for example, if we were to substitute sub 4, right, and then we get let's say 18 and 24, this would be wrong. Why? Because now that means for one X value you're getting 2 Y values. We don't want that. We don't want that. Right? So you can see here, each and every X value produces only one corresponding Y value. We don't have a single X value, right, that produces more than one Y value, right? Yes, but it's possible to have one Y value being mapped to more than one X values. I don't know if you guys get what I mean. Okay, the Y value, the range needs to be unique. In other words, the outputs that we're getting, they must be unique. We can't be having we can't be having inputs, right? We can't be having one input giving us different inputs, right? In other words, an input needs to give us a unique output. Okay, an input needs to give us a unique output, and the output needs to be only one. Okay, no one input can give us two outputs that are different. I mean, that doesn't make sense. It doesn't make sense that we can add tea, right, to our hot water, and then we get coffee and tea at the same time. It doesn't make any sense. That's why we're being restricted that, okay, if you add a tea bag, you must be getting tea. You can't be getting two things using the same input. Right? So an input needs to give us the same thing, right? The same output, right? So I've sort of like tried, to explain it, but hey, if you still don't understand, I don't know, but I am very much confident that you guys managed to, grasp these things. All right, but the idea is the X values must give us only one Y value, right? So in other words, whatever X value that you're substituting, it must give you one y value. Okay, and even if you've got two x values giving you the same y value, that is fine. Three x values giving you the same y value, it's fine. But once you're substituting one x value and then it gives you 2, 3, 4 x values, that's wrong. Not x values but y values, that's wrong. So you need to have a unique, range as per input. So ladies and gentlemen, we have come to the end of the lesson. It was it seems like as if it was long, but I hope you guys learned a lot. And yeah, if you've watched this video, you are probably set up for the topic functions, and we're going to do a lot more examples. Remember, there's still the vertical line test. We're still going to cover that, so stay tuned, and peace out. I'm out of here.